Hello, everyone. Welcome to the fourth developer community meeting. Not a lot of people here. That's okay. I know midterms are around this time. Hey, no problem. Today, we're going to be going over natural language processing, and we're going to be going over this competition called Disaster Tweets. As always, you can stay connected. Here's the QR code to our link tree, our Discord, our website, and our Instagram. So let's go over this Kaggle competition. Let me send it in the chat. So this Kaggle competition is about looking over tweets, and tweets are basically posts on Twitter. We're going to be going over tweets on Twitter to see whether there's a disaster going on nearby the person actually making the post, or if the tweet is about a disaster going on. And the data involved, it's going to be some text with a keyword, location, and the text is a Twitter, is a post. Right, so let's get into the notebook. So for things up, this is the standard code cell that shows up when you make a notebook for a Kaggle competition. I added re and NLTK. Re is the Python regex library, and regex, it's like patterns that you can find in text data. And I also imported NLTK. NLTK stands for Natural Language Toolkit. It's a library with a lot of tools to work with text data. So running this code cell. And this is just printing out what's in the input here. So let's read our data. We're going to be using pandas to make our data frames. And here we have our rows. We can use the head to see the first 5 rows, as always. And this link, I got it from copying this file path, these file paths over here. You can just copy and paste them. We got our train head, df test head. Let's see how many missing values. There are a lot of missing values this time around. There's 61 in the keyword column and 2,533 in the location column. So that's actually pretty bad, especially when you're working with text data. You don't want to remove any of the data because it's so precious. So what we're going to do instead of removing text data is remove the columns with the missing information, because it's kind of hard to fill that in. So let's drop both of them. Now we can see what keywords we're working with. There's a lot of them here. We're just going to drop. And in the end, we're going to have an ID column, a column with text, and our target column. And the target column, 1 means that there is a disaster going on. 0 means that there is no disaster going on. And our test data doesn't have a target, because that's what we're going to be submitting to the competition, our predictions to this text data in the test data frame. So it's actually, I'm going to separate the ID columns, especially the one in the test data frame, because I need to save it for later when making my submission. But for training the actual model, we don't really need the ID column. we can go see what it is now. It's just for our training, it's just a text and the target, whether it's a disaster or not. And for our test, it's going to be just text that we're going to be predicting on. So now we're going to get into some pre-processing we have to do for text data. And the reason this is going to be a little bit more verbose than other pre-processing we've done is because computers, they do not like working with string data in its text form. It likes numbers. So we need to make sure that our string data is good so that when we turn it into numbers, the computer doesn't get confused. For example, typhoon devastated. This dash here and this typhoon devastated over here together, to a computer, these are not the same word, even though they have the same words in them. But to us, we know, oh yeah, for sure, this is the same. This is talking about the same thing. But like I said, a computer doesn't know that, so we need to change it so that it's similar. And I just got this from another notebook where he did a bunch of grammar checking on the text data. And you also need to get rid of special characters like ats, hashtags, emojis, Japanese letters. And you can also get rid of contractions. So he into he is, there into there is. There's a lot of them. And just to make life easier, let's also remove all the non-alphabetical characters. So this is numbers. We don't want numbers. We don't want any other special characters like HTML tags, URLs, or anything. And speaking of URLs, there's another one here where I can remove from string. And we're going to have lowercase everything. And the reason we want to lowercase everything is, like I mentioned, even the slightest difference in the string the computer will say, okay, this is a different word. So if I were to input to a computer typhoon and typhoon, to us, it's the same word, but to the computer, it's two completely different words. So we're going to lower everything just so that it's the same. Those functions. And here I just made one function to have all the other functions. And now I'm going to apply this function to all the text data in our data frames. It's going to take a while. There's a lot of searches, but we can go ahead. You have train, we can see our text, our target. And if you look at the text over here and the text all the way over here, you can see there's no more hashtags, no more capital case letters. It's a lot cleaner. And now we are going into the model portion. So what we're going to be doing is we're basically going to be counting the words. So we're going to be counting how many times just happened a terrible car crash, how many times each of these words happen in this sentence. And it's going to be for every word in the entire data set. So, but before we do that, we need to turn these words into numbers, like I said. And to do that, we're going to do count vectorizer from Scalar. And what this is going to do, it's just going to transform every word into a number. So it's going to turn, let's say, just happened or just into 0 or happened into 1, A into 3, stuff like that. So that we can do that. We also combine our data sets so that we can fit our count vectorizer on all the data. The reason for this is because if we don't, and there's a word in our test data that's not in our training data, when we actually go to transform our test data, if the count vectorizer isn't fit with all the data and it comes across a word it doesn't know, it just says, okay, this is a null value, or this is a 0, or a space. So it kind of just removes the data. So we don't want that. So let's combine our data frames, fit our count vectorizer on everything so it has a good vocabulary, and then we can transform all our data. And here I'm just printing out what one of these transformations looks like. It's more of a vector here. It's like one hot encoded. So I can't really show it right here because there's a limit to how much the array shows. Let's train, just split our data. We're gonna train it, we're gonna split it into train and validation, just to make sure our data isn't going whack. And let's have our naive Bayes bag of words. Naive Bayes, it's a model that basically works with probability. So based on the count of words in each of the rows, it'll predict whether it's in a disaster or not. So we have our predictions, and we can check out our accuracy. It's actually a little bit worse than the last time I did this. So let me actually redo that. I want at least a 63. Good. All right, guess it's not going to happen. But we can go ahead and read in the sample submission, just so it has a template. And we can change the target into our predictions with our model for that test data. And then set index ID. This is just so that the primary key column is the ID column, or the index column, if you want to call it that. And we can output our CSV and submit that to the competition. For this competition, I'm pretty sure. Let me see. Yeah, I got 62. And I wish I could. Here I am. 774 out of 850. It's pretty bad, but there's ways to improve it. Right, and for the deployment. So since we're only working with scikit-learn models, there's not really a function in the model to save it like in TensorFlow. So we have to use the Pickle library. And what Pickle does is serializes objects in Python. And what does that mean? It saves it into a binary form. I don't know how to explain it better than that. It basically turns it into zeros and ones, and you can load it in elsewhere. So here we're going to save our model, and we're going to save our count vectorizer. The count vectorizer we need to save because when we input our own data in our web app, we need the count vectorizer to transform the text into numbers. So we can do that. And the output for this notebook is in this output tab over here and it's working, and you can just download it from here. And I can share this. Oh my God, I forgot to share this in the chat. I'm so sorry. Also share it in the Discord when I finish this workshop. Right, going to Streamlit now. I promised I was gonna show how to go into the virtual environment. So you can create a folder, let's say a sample folder. And you want to open up your terminal to the base of this folder and go cd into the folder you just made. Once you're in the folder you just made, brand new, hopefully you have virtual env installed. Virtual env. And if you don't, you can pip install it using pip install virtual env. But once you have virtual env, you can do virtual env VM or whatever name you would like for your virtual environment folder. I just use VM just because I like that. And you can create your virtual environment folder. Right now it shows like this weird because that's the only folder. So let me put a file in there. You can see that's your VM. So what is that? That's your virtual environment. You can activate it like I have mine activated right now by cding or running. If you're on Windows, the activate.bat file. If you're on Linux or Mac, you would run the activate, just activate. I don't think there's a .sh or yeah, this one right here, this activate right here. So if you're on Windows, you would do activate or you would cd into VM, you would cd into scripts, and you would do activate that. That's for Windows. But if you're on Mac or Linux, you would do the same thing, go into VM scripts, but instead you would do /activate, and this would activate the environment. And how do you know it's activated? It would have this VM in parentheses here. And what does that do? Well, once you have your virtual environment activated, it's basically a separate environment from your main environment, from your base environment. So let me show you what I mean. If I do a pip list here, which is going to show all my Python packages I have installed using pip, you can see I have a lot of them. There's a lot of them here. But if I open up a command prompt, and this is my base environment, if I do a pip list here, you see that I only have a little bit. I don't have as many as I have over here. And that's the useful part of virtual environments. You can have an environment separate from your base environment where you can experiment, install anything you want, and then when you're done with it, you can just delete it. For example, now that I'm done demonstrating this, I can just delete this. It looks like it's busy, so I'll do that later. All right. So let's go into the stream. So I have two files I'm using right now, app.py and helper.py. So in helper.py, I'm gonna load my account vectorizer and my model. I'm using the same names just so it's very clear. And over here, I get the path of this static folder where I have both of these pickles. And I have this get prediction function where first I pre-process the text. I just copy and pasted all the pre-processing functions into this helper function so that I can pre-process the text I get into this function, transform it with my account vectorizer, and then predict on that transform string and return my prediction. So when I go to my app, I import my helper functions, import Streamlit, and then I do an scwrite. Scwrite, when you do scwrite, what you're actually writing is markdown. So it's a string using markdown. So in markdown, this would be a title tag, disaster tweet classification app, and this would be like a heading 3 app tag based on this. And this without a tag or these hashtags, this would be like normal text, like a paragraph tag. And this in markdown is just a horizontal line. So first I want to get a string from the user. So I do input string equals sc.textInput. This is a widget that's basically a text box where you can input, where you can type in, and make the max characters 280, which is the same as the max 1 characters for a tweet. And then I set my prediction variable first to -1 because when the user presses the button, I'm going to get the prediction from the input string. And the prediction equals 1, that means there's a disaster. So the model predicts your text is about a disaster. And if not, if it's a 0, or if something went wrong and it's still -1, it says your prediction is not a disaster, or your model is not about it. Your text isn't about a disaster. All right. So with that done. And by the way, to actually share these apps using Streamlit, you have to make a GitHub repository with basically all your files. They're static. You don't have to have a static folder. You can just have the models here somewhere and load them in that way. And a requirements.txt. I showed this last time, but I'll show it again. The way you get this requirements.txt, you go into your terminal, you do pip freeze. This is going to get basically a pip list, all your packages and their version numbers. And you can do this greater than sign to redirect it to requirements.txt. But I'm not going to do that again because I already have one, so I'm going to do sample rex.txt. And it's somewhere here. I have it outside. Where is it? Symbol. Oops, I have it here. I was still. Anyways, here. You can see what I mean. It's every library with its version number. I like keeping track of what libraries I'm actually using so that I can delete all the ones I'm not using here so that it doesn't install these for no reason. Like matplotlib, I'm not using matplotlib in my app, but if I leave it there, it's just gonna install it for no reason. So I like cutting it down here's the requirements.txt I have for this app that I'm going to show right now. All right, so if I go back to the web app, you can see here it is. As you can see, the H1 tag, that's the one hashtag. The tags with the H3 tag, the paragraph, the horizontal line, and here's the text box. If I want, let me think of a tweet to put. I'll put one I showed Sebastian earlier. Volcano yeet. Let's predict on that. And the model predicts that my text is about a disaster. And obviously it is. And that's pretty much it. If there's any questions, feel free to DM me. My DMs are always open. I'm also going to be on Discord voice calls if you ever need me. So thank you for watching or coming. And that's it.